Good afternoon, all. Thanks for joining us. Just give us a hand up or a message if you can't hear me or you have a question, no problem at all. We've got about half an hour, so we're okay for time. This Plant 3D to Advanced Steel workflow is something that we come across because most people have the AEC collection, but not many people seem to utilize it too much. So I'd like to take you through some of the procedures that you need to change from one to the other. So my name is Warwick Sullivan. I've been with A2K for a number of years and been in a few different industries, including mining and some other bits and pieces. But my role here is a technical consultant. And let's have a look through this. What we'll do, we'll just kick off here. Probably what I find going from one client to the next, a lot of people will know exactly what the deliverable is, but some others are still trying to work out what is actually possible to deliver as a deliverable for the client. Sometimes the client will know exactly what they want as well, but I've just put some notes down here. Let's go through. The most important part of any project is knowing what the deliverable will be, and having realistic expectations of what is exactly possible with the time frame that you might be given with the available tools and skill sets that you've got. So I guess, yeah, just stick your hand up if you think you've had similar sorts of problems yourself as we go through these. What we'll explore in this session is the capability of communication between AutoCAD, Plant 3D, and Advanced Steel as it sits at the moment. I think there could be room for development in the future, but at the moment, let's just explore how it is out of the box, so to speak. So I guess a valid question you can ask yourself and to others responsible for the collaboration model is what is logical and relevant to the output to actually get the job done. So that's probably a question for you guys. You can have a think about that and talk amongst yourselves at work. So that's probably a key thing to establish first. The next thing that we've got to battle is the level of detail and how does it affect you as a CAD administrator or as a CAD operator. Lots of talk about the different levels of detail flies around industry and meetings these days, but at the end of the day, you need to do what's required, I guess, just to get the job out the door. So I guess you could say this is very important as every project has different requirements. I've noticed even in industry that I come from with mining and water treatment places have a lot of different requirements of what the actual deliverable might be, and that'll have an impact on the chosen tool set performance. So you always try and use the right bit of software to do the job. Often I'll see a lot of people misusing different lots of software, trying to make it do things it was never designed to do. Sadly, obviously AutoCAD could be one of those victims. You probably have a laugh, trying to make it do things it just doesn't. So your level of detail must be established at the start of your project. This will make it a lot easier downstream when you have to actually start producing the 2D drawing. So obviously the nice 3D stuff keeps us amused and interested, and it's a really great central source of truth. But keep this in mind as we go through these next steps, because the detailed design will normally come off the model as our central source of truth. So how do we start this? So what steel sections will be required for the job? So you need to identify that first, and what catalog you think you might need if you're coming from Plant 3D. If you're in Australia and New Zealand regional area, you can actually download the Australian New Zealand steel content is available from the Plant 3D section in the Autodesk app. So you can download that there. If you need a link, just send us a message later. We can help you out with that. It's pretty easy to find. You type in Plant 3D content, it'll pop up pretty quick in a Google search. So forward from there, I guess you need to identify what level of detail is required for your model, Plant 3D model, and what if any advanced steel level of detail is needed to transfer back into 3D, Plant 3D. So that is probably a bit of a critical question as well. It could be a one-way street. So you might not want to bring back the highly detailed model back into Plant 3D, or you may need to because you might have, you know, bolted connections established with bits of equipment and so on. So that's probably another thing you guys could, you know, talk at work about what is actually required. So there's no point bringing it back if you don't want to, but it's more no problem to do that. And you'll see that towards the end of the presentation anyway. Right, so we do actually have to do a bit of preparation for the Plant 3D models. The 2D documentation for a project output can be a time-consuming job if not prepared properly or badly structured project model breakdown. So that is to do with the project tree in Plant 3D. This will cut you off the knees if you don't have that set up properly, if you've got lots of people working with you. So many people will try and cram too much into the one model file. That's okay if you're XREFing stuff in, I guess, but not if you've got lots of, if you're mixing the pipe, you know, the handrails and the steel all together in the one drawing, you're going to suffer a little bit. So just think about that before we go to the advanced steel section. You'll have more flexibility and easier time if the model elements are broken down into individual files. So people always go, well, that's going to take longer, or we're going to have too many files, but it's really not the case. It'll actually help you hand pick out exactly what you need in the 2D drawings, as well as trying to filter out stuff you don't need when you bring it across to advanced steel. So this will accelerate your speed of the design process. So you can utilize multiple files per large equipment if you wanted to, including obviously steel, and also layers, the good old layer manager to assist this process for large projects. This practice will set you up for easy transition between Plant 3D and advanced steel. So, and stay tuned, A2K will soon be offering advanced workflows for the actual tools to assist in this area. If you're interested, just let us know with an email later. So let's get started. Firstly, I've created a plant steel structure that we can have a look at. Using the layer manager, we can allocate items with the drawing file per layer for better control. So that will actually save a lot of time. I've seen some other presentations from others doing this, but it seemed to me pretty obvious. If you just use some of the traditional tools, it'll actually make it life a lot easier. You'll find it's very quick in Plant 3D to create structure to support your plant layout, utilizing copy and mirror, which is supported for Plant 3D in the steel section. Plant 3D will create a grid if you need to, but I find a polyline is just as fast to do an actual layout there as well. So at least the 3D polyline or the grid gives you something to physically click on when you're placing those steel members to go into advanced steel. Plant 3D also supports AutoCAD XREF functionality, so this is actually a lifesaver. This is the best way to break down the design into manageable size elements. So the reason why I put this information in here is because you'll have, if you've broken up your drawings into, you know, it might be per area for each steel structure that you might have done in Plant 3D. It's very easy to export that out into advanced steel without having to go through it like a fine-tooth comb, as an example. So you guys can hear me okay? Just send us a message if you can, just in case it's dropped out, just let me know. Let's have a look here. Create. Okay, cool, thank you folks. Create a new file, new model file. So you can see here in my image, I've got a basic steel pipe rack kind of a system with a bit of bit of a walkway there as an example. So in the Plan 3D Project Manager tree, under the required folder area, create a new model file. So you can see that there happening. Now, I guess we could build a wireframe to place the members, which I was saying before, which is a good idea. It's good to create a non-plot layer for grid and wireframe. So whether you're in advanced steel is probably a bit easier in some ways, but if you create a structural, I guess you could call it like a detail layer where you can click things onto with literally 3D polylines, makes it a lot easier. Set that to non-plot. You can see the green lines in the image there. Plan 3D. In Plan 3D, set the required steel profiles to build the structure. So you'll need to obviously pick out the bits and pieces if you haven't used the steel structural part of Plant 3D before. It's pretty easy to use. After the model is complete, we'll isolate the components that are not required. So that statement there that I put in these notes is pretty critical, because if you've got handrailing, grading, stairs, ladders, for an example, to be honest with you, you're probably better off doing those elements in advanced steel, because a lot of those elements actually come from a catalog item, catalog that actually brings things in like web forge, monowheels, you know, maybe stair catalog parts, handrailing, all that sort of stuff. So that will be a better way to go. I have put handrailing in here as a placeholder. So if you did want to leave it in there, that's no problem. You can bring it in. But I always think that it's probably better just to leave it out, to be honest. So you're just exporting the steel beams on their own, but we'll see that in a minute. So after the model is complete, you can isolate those. So I've put them on different layers, so you can just use the layer isolate button in like literally like 2 seconds without having to pick 600 little bits and pieces if you like, or just literally open the layer manager and freeze it off. So I've just written here, if you prefer not to bring in the handrail, stairs, grading, you can even unload the XREF or freeze off the layers if not required, depending on how you've structured it, no problem at all. So let's keep going. Plan 3D to advanced steel export. Now, if you want to have a look, you're probably, it wants to export an advanced steel, what it thinks is an XML. That's what's written on the actual button itself from Plant 3D. So you'll need to go to the structural tab on Plant 3D. You want to write that down. Do a screenshot for yourself. So go there first, and you'll see that there's an advanced steel. There's an advanced steel export button there. This will bring up the selection function to extract the required parts. So if you have a look down here in the bottom image, you can see it's saying output file. It's pretty important, obviously, you want to name that, and then there's a browse button over to the right here. We will actually allow you to save it somewhere. And then you can see there's a selection button in here as well to actually grab the steel members that you want. And you can imagine from the comments we made earlier, if you've used layers properly, if you've got your drawings managed properly, this will take 5 seconds. So you can eliminate the white noise that you don't want to bring across, and you've got everything you need here. So let's move on. So you can have a look here. Up the top, we've got select steel to export. So now it's time to select the steel members to export using the tool in the last slide. Using the select button on the dialog box, choose the sections and save it to the working folder that you've got. All right. Let's move on. So now, once you've got it saved, probably a little bit of an open conversation here. We need to import this from your working folder into advanced steel. So obviously you need to have advanced steel open, of course. You need to create a drawing, the warning here, right? Use the advanced steel template if starting from scratch. So if you have a look here, there's a feet and inches one. You want to dodge that, being in Australia and New Zealand. you want to use this template here, it's metric. So now we need to navigate to export and import on the tab for the advanced steel ribbon. So what it wants to bring in, or what it's exported from advanced steel, is actually a SMLX file type, which is a bit unusual because it says XML on the last one, so it's like a little bit confusing. So at least you're aware of what it's going to go looking for. Here is a snapshot of the ribbon for advanced steel. So if you have a look on the left-hand side, this is where you can see the Revit, R for Revit, and you've got import with the orange oval over it. That is the tool that you're looking for to import back in. And on advanced steel, it's on the export and import ribbon tab. Okay. And you need to navigate to this file again, no problem. So let's keep going. You have a look here. This is one thing that probably was a bit of a shock to me, I guess, the first few times I did it. I wasn't expecting to have to do this. So hopefully maybe Autodesk will make more improvements on this workflow, but at least after watching this presentation, you'll have a bit of a heads up, like I did not have, I guess, when I tried to do it. So what it's trying to do, even though I've got an Australian steel loaded in Plant 3D and using it, in advanced steel, it still wants to map it, right? I don't even know why they, for me, it looks like apples for apples, but it still wants to map it. So we're gonna have to deal with that for the moment until they improve things. Or if you need some design content help from us, we can help you set up templates so you don't have to do this every time. Just let us know in some emails if you like, and we can have a chat offline. So you can see here my procedure I've got, it says use, save Australian steel on the template after the import if needed. So you can do that. So what that means in English is that after you import the Australian steel from Plant 3D, you can overwrite, if you like, or do a save as onto your own template that will actually, each time you import, it's very important to listen to this, if each time you import a piece of steel from Plant 3D, if you do that in this template and save it over it, it will remember that it's in there and you don't have to do it a second time. Right? You don't have to do it a second time. But if you need help with that, let us know. Here it says use sections in the drop down to select the correct standards. I've got obviously Australian standard, ANZ standard, UB, universal beam section shown here. So if you have a look here, you've got sections. You'll need to click on this as you bring it through. Select the Australian universal beam if that's what you're bringing in. I'm just assuming. Apologies if it's something else, no problem. And then over here, you can see the section that I've used on this occasion is the 150 universal beam, right? So then you can marry it up. So it's a one-time thing each time you do it, but like I said, you can save that back over on your template if you want to. Then match the steel section in the drop down, which is this here. This is me talking here. So we'll keep going. Right. Now, if you have a look here, we've got ready to do some detail for your Australian steel model if you wanted to. So you could try and do a cut or a connection just as a test. Or if you want to do like a bolted connection or something like that, it's probably a good test to have a go on your own first before you implement this into your business. Or if you have a fully detailed model, you should be able to import that straight back into Plant 3D as an XREF. Okay, so that's the way to do it. And you can easily unload, reload the models, which works well. So let's continue. If you have a look here, I've just made a quick example just for something to look at. See here, there's an example. You can make a modification to bring it back into Plant 3D. So what I did, my quick procedure was I did a cut to allow the advanced steel tooling tool set to actually make a connection. Don't laugh at my connection, there's my little connection. And I've also put in some cool looking realistic handrail from advanced steel, which looks way better than my Plant 3D effort. So you can add that in, see the bolted connection. So you've got a real thing to bring back in and see how it reacts. So let's move on. Right, so now we finally get to go back to our beloved Plant 3D. If you have a look here, we've got the model loaded in, right? So we've got, now it's time to unload the old Plant 3D model. So you can just unload the XREF, and then you can reload the advanced steel model straight in underneath where the other one was, which works great. And congratulations, folks. We've actually made it to the end of the slides and our presentation. So here's our advanced steel part back in there. I've got it highlighted in blue, so it looks good. But I've got just a few minutes left. So if you guys would like to just throw some questions at us, no problem. I'll try and answer them as best possible. And also maybe let us know if you think you might give it a go as well after watching this presentation. We'd love to hear from you. Okay, folks, over to you. Let us know what you think. In the short term, folks, I'm just going to try and bring this across. Tell me if you can see it. This is actually the model that's come back into our screen share. So can you guys see the Plant 3D interface? Just give us a yell. How about now, folks? Can you see it now? Okay, cool. Yeah, sorry about that. If you have a look here, just while if anyone's got any extra questions, I'll just zoom in. There's the actual advanced steel model it's brought back in. It's come in as a transparency, which is interesting. And you can see the bolted connection straight from advanced steel there. So as an example. And what I'll do, I'll open up the actual button. So we go to structure. Can everyone see the advanced steel export tool? So that's what you're looking for when you get into your Plant 3D and you want to export. So look for that one. And if you have a look here, I'll just open up the XREF manager. And if you have a look here, see what I've done? I've actually unloaded the original steel model and I've got the new Plant 3D steel model imported from advanced steel reloaded in there. So it's very easy swap over and the thing arrives exactly in the same spot, which is great. Now, what I'll do now also is I'll show you the tools for the advanced steel import. Just let me know when you can see this. Can you see the advanced steel interface, folks? All right, cool. Thanks, Daniel. Cool. If you have a look here, I'm on the, well, obviously there's the home tab, right? But you guys and girls want to go to the export import. So cruise over here. And if you have a look, there's the import tool there. And thanks, Mohammed. And I'll select that. Check this out. Just guys, girls, write down this s.smlx. That is the actual thing that you're looking for, right? So once you import that, we'll go open, and you'll end up with the 3D model in here. The only tragic part is you have to map the members, you know, to bring it in the first time. But I've been doing it progressively, and there's like less and less to do each time. So it's actually a really fantastic tool using advanced steel. I've done steel detailing in other programs like Inventor, and it's purely just hard work. So you can see the Plant 3D style handrail looks terrible, right? And check out the great looking advanced steel handrailing, realistic, and it's from a real catalog with real connections. All good? Oh, here we go. To get this model into Revit, retain all the parameter info. Would you export IFC, then link it to Revit, or is the advanced steel add in for Revit better? You could probably try the add-in first, but Ian, we're actually going to also do some workshops between those two as well. So I'm booked in to do actually Inventor into Revit. And I'll check with the guys here to see if someone's doing the advanced steel into Revit and see what the best workflow is. So Ian, if you could send us an email after this, and we'll get your input and your ideas, and we'll see what we can do with it as well. Thanks, Ian. That's cool. Great question. Oh, Ewan, hello, old friend. When you bring this back into Plant 3D, does it look how you create an author view? It comes back in as a 3D model. I haven't tried it as an author view. We can do that together offline when we get a second. Is it just shown as a phantom, or is it pretty sure it comes back as a proper AutoCAD object actually? So, but yeah, Ewan, we'll give that a go. Any other questions, folks? We've got about a minute to go. So, oh, here we go, Dan. Thanks, Daniel. Hi. What about level of detail when making drawings in Plant 3D? All of the bolt connections from advanced steel too much. Well, you know what? That's a really great question. Thanks, Daniel, because I guess the intention of Plant 3D is not to overload it with detail. But from the 2D, if you're doing outputting 2D drawings, and for the steel itself, you can't go past advanced steel. But Daniel, if you're doing high-level plant layouts and stuff like that, you probably don't want the nut and bolt detail in there. You just want, you know, length, size, and width and stuff like that. David, is Plant 3D part of it? Yes, normally it is. Thanks. I could hear your response, but I did not hear that you have. No, I haven't tried it yet. You and we'll try that ourselves on Monday if you're about, no problem, or this afternoon. All right, folks. Yeah, thanks, Mohammed. It was great having you. Let us know your thoughts and ideas. We love. Yeah, we can try and get you a copy of the presentation if you like. And also give us some feedback with some emails, whether you liked it, what you thought, what we'd like to see next, and things like that would be fantastic. Because we're going to do a lot of these. Oh, sorry. Yeah, send us an email, no problem. Thanks, Ewan. Yeah, I think the idea is that I think you guys and girls will get a copy of the actual recording of this. So yeah, no problem at all. If we can might even be able to convert it into a PDF for you if you like. Just let us know. Yes, you and I think we can download it. I think they're actually posting it on YouTube and they share it with you guys, from what I understand. All right, folks. Thanks for that. If there's any more questions, we'll take one more question if you like, and then I'll let you get back to your work. Thanks, Ian. Cheers. And thanks to everybody else who had time to dial in. Much appreciated by us. We had quite a large turnout. I'm in shock. So thanks very much for the loyalty, and we'll always look after you here at A2K as best as possible. All right, thanks, guys. I'm going to stop the share and. Oh yes, thank you. We'll see you again soon. We'll have some more with Inventor to Revit, and we'll try and cook one up for Revit to Advanced Steel and back as well. And also probably we'll do maybe Plan 3D into Revit is a pretty hot topic at the moment. Let us know your thoughts and ideas. Okay, guys. Thank you.